Hello class, this is Mr. Hart, and in this podcast we want to finish up the coordinate geometry and volume unit. And so we looked at volumes of prisms and cylinders, and the last thing we want to do is look at volumes of pyramids and cones. Okay, and how I like to think of a pyramid or a cone is just a triangle in 3 dimensions. Okay, so pyramids and cones, they can have all different types of shapes because they can have all different types of bases. They can have square bases, triangle bases, pentagonal bases, circular bases, right? So pyramids, there's any shape as a base, and then a cone is specifically when we have a circle for our base. So these two would be pyramids, this one would be a cone. Okay, and so it's similar to a prism, right? You start with some type of area along the bottom, but now instead of extending that shape up, you're extending it to a point at the top. Okay, that's kind of how pyramids and cones get their shape. You start with some shape on the bottom, but now you're extending to a single point instead of the whole shape itself. Okay, so we can treat it similar to prisms and cylinders, okay, but our formula is going to be a little bit different because we're not extending that whole area just to a single point. Okay, and so the formula for how we find the volume is given by 1/3 the area of the base times the height of the solid. So you'll notice it's very similar, area of the base times the height of the solid, but now we have to times it by 1/3. Okay, now in class we kind of went through a proof to show why this is. I'm not going to take the time to do that right now. Okay, but the way I like to think about it is a triangle, the area of a triangle, for example, for the coordinate geometry was just 1/2 the base times the height. So how I like to think about where this 1/3 comes from is this is a triangle in 3 dimensions, whereas this was a triangle in 2 dimensions. So instead of being 1/2, it's now going to be 1/3. Okay. Now again, there's a better explanation, better proof, but just kind of a way to remember it is your triangle is now in 3 dimensions, so now you have to times it by 1/3 instead of by 1/2. Okay. But either way, the point is the volume is 1/3 area times the base times the height of the solid. So we find the area along the bottom, times it by the height up to that point that it's going to, and that's going to give you the volume. And again, we have the nice feature that this is also the case for cones. Okay, so it's still 1/3 area of the base times the height of the solid, but now we're doing it with a circle on the base, so you still use pi r squared. But exact same formula, just have to find the area a little bit differently. Okay, so this is really nice because we can treat them exactly the same. Okay, so let's go ahead and try an example problem. Sorry, the picture's a little fuzzy, but we're trying to find the volume of this pyramid. Okay, so we know that the volume of a pyramid is 1/3 the area of the base times the height of the solid. Okay, so let's start by finding the area of this base. The base right here in this picture is a square or a rectangle. Okay, and so we can treat it as a rectangle, right? It's a square, but let's just treat it as a rectangle. So it's going to be the base times the height, and again, it's the height of the rectangle, not the height of the pyramid. Okay, so that's just going to be 9 times 9, which gives us 81. Now we plug that back into the formula. Okay, so the volume equals 1/3 the area of the base times the height of the solid. In this case, 1/3 times the area of the base is 81, and the height of the solid is 12. You put that all through in your calculator. 81 times 1/3 times 12, and that will give you that the volume of this pyramid is 324. Now again, we're still working with cubic units just like in the last podcast, and so we're going to be doing meters cubed. Our units for meters, this is a volume, so they need to be cubed. Okay, we're working in 3 dimensions. So there we go, that's the volume of this pyramid, 324 meters cubed. Okay, let's go ahead and try one more problem just to make sure we got it down. So now we're trying to find the volume of this cone. Still the same formula. The volume of a cone is 1/3 times the area of the base times the height of the solid. Okay, but now the area of the base is a circle because it's a cone. So we're looking for that area of this circle right here. Okay. And so it's giving us that this line right here is 6 kilometers. And so that's the radius of the circle. Okay, the radius is going to be 6. So now we can plug that in to the area. So the area of the base is the area of a circle, which is pi times r squared. R in this case is 6. And so that's going to give us 36 pi. Okay. And as before, I'm going to leave this as the exact answer for now. Okay, so the volume is now 1/3 times the area of the base times the height of the solid. So that's going to give us 1/3 times 36 pi times the height of the solid in this case is 12. Okay. You'll plug that in your calculator. Okay. 1/3 times 36 pi times 12 is going to give us 144 pi. That's our exact answer, or we can plug in the pi and get the approximate answer, which is 452. Okay. And I kind of ran out of space, but if we want to make sure we have the right units, this is in kilometers, and since we're working with a volume, that's in 3 dimensions, so the units will be kilometers cubed. Okay? So it's exactly 144 pi, or approximately 452, okay, kilometers cubed. So that's our volume. Okay? Alrighty, but hopefully that all makes sense. That's our homework for today, is finding the volumes of pyramids and cones, which is very similar to finding it for prisms and cylinders. You just have this extra 1/3 factor that you need to account for. Okay? Hopefully that all made sense. Let me know if you have any questions, and thank you for watching.